Smart culture, science.
In this experiment, we will explore a concept called interference using a simple ripple tank setup. You will see how waves interact with each other, sometimes combining to make bigger waves and sometimes cancelling each other out. But before we begin, let's define two key terms. A pulse is a single disturbance that moves through a medium like water. When you tap the surface once, you create a pulse. And then interference happens when two or more pulses meet in the same space. They can either add up, then we call it constructive interference, or they can cancel each other out, and that we call destructive interference. To set up our ripple tank, I used a plastic lid. This acts as our shallow container. Then I have 4 tall decanters or glasses to hold the lid above the surface. Then I have a lamp, which will be our light source, and a white sheet of paper. Now I place the white sheet of paper underneath to help us see the wave patterns. Then I fill the lid with water, just enough to make ripples visible. Now I will create a single pulse. So I gently tap the water with one finger. This creates a single circular pulse that spreads outward from the point where I touched the water. So the pulse travels through the water because of energy transferred from my finger to the water particles. Each water particle moves up and down, passing energy to the next one. Now I will use 2 fingers to tap the water at the same time. This creates 2 circular pulses that move outward and eventually overlap. When the pulses overlap, where 2 crests meet, they add together, so that's constructive interference. And where a crest meets a trough, the low point, they cancel each other out. That's called destructive interference. This creates a beautiful interference pattern. Next, I use 2 fingers again, but this time I tap slightly out of sync, so the 2 pulses don't align perfectly anymore. Because the waves are out of phase, the pattern becomes more complex. Some parts still show constructive interference, but it's not as symmetric. Timing plays a key role in how interference happens. Now I will switch tools. I will use a pipette. So I suck in some water and let a small drop fall back into the tank. This creates a single pulse, similar to the one made with my finger. So the falling water drop disturbs the surface and starts a pulse. This method can be more controlled than finger tapping. Finally, I use 2 pipettes to drop water at slightly different times. Again, 2 circular pulses are formed, but they don't line up perfectly. So the interference pattern shows mixed constructive and destructive zones depending on where the pulses meet. Since timing is different, the symmetry is not perfect. So let's have a look at this water wave interference pattern. So 2 point sources emit circular ripples. So that can be the water drops from the pipette or my finger. Where crests meet crests or troughs meet troughs, we see constructive interference. Where crests meet troughs, we get destructive interference. This matches what we saw in our ripple tank experiment. Through this ripple tank experiment, we've seen how waves interact through interference. By using just simple tools like fingers or pipettes, we can model complex scientific ideas in a hands-on way. This wave behavior isn't limited to water. It applies to microwaves, sound, and even light.
And that's a wrap on today's fascinating journey through the world of knowledge. Don't forget to hit that subscribe button and join our ever-growing community of curious minds. We can't wait to embark on new educational adventures together.